A topic that is closely related to I/O and CPU-bound tasks is blocking versus non-blocking operations. The difference between the two in Node.js lies in how they handle input and output tasks. Blocking operations pause the program's execution and wait for the tasks to complete before moving on. In contrast, non-blocking operations allow the program to continue executing other tasks while the operation is still in progress. In blocking operations, the program's flow is halted until the I/O operation, such as reading data from a file or waiting for a network response, is finished. This means the system remains idle and cannot process other tasks until the current operation completes, which can lead to inefficiencies, especially in applications that need to handle many tasks simultaneously. In the case of non-blocking operations, they allow a program to keep running other tasks while an operation is ongoing. The system doesn't wait for the operation to finish before continuing to the next task. Instead, it can execute other tasks and handle the results of the I/O operation when they're ready. This approach is commonly used in event-driven or asynchronous programming. Node.js uses a non-blocking, event-driven architecture. It employs a single-threaded event loop to manage all incoming requests and I/O operations. The event loop queues I/O operations and then executes their callback functions once the operations are complete. This efficient process enables Node.js to handle a large number of concurrent connections without creating a new thread for each connection, which would be resource intensive. For CPU-bound tasks, intensive computations can block the event loop and degrade performance. Node.js uses worker threads, which we've already covered. These worker threads run separately from the main event loop, allowing the event loop to continue managing I/O tasks without interruption.